So how do we get to derive this? Remember, your prism is going to look something like this, but all of this will be done in the class, like I said, and this is just going to be a clue to the derivation so that you can get the derivation in the simplest way possible. All these values that we have here, what does it represent? We have that from the geometry that we have from the circle, from the triangle, we have what the each of the variable represents. We see where each of them are located on the triangle, right? So now let me take you to the board. For any given incidence, this is going to be true. At minimum deviation, the refractive angle, the two angle of refractions are equal. So since the two angle of refraction are equal, we just call them one angle. We just represent them by one angle, which is R naught. And then the angle of incidence and the angle of emergence are also equal. Then we just name them one angle, which is what? I naught. Now, at minimum deviation, this is true at minimum deviation. Now, this equation we have here is going to alter the original equation that we have in this place. We have that R is equals to R1 is equals to R2. Then, and we say we are learning them just this. In other words, we're just going to be having R1, R naught plus R naught, and that's just going to be what? 2R naught. And then from there, we can make R naught sort of formula. And then we have that the single refraction we're going to be having here is going to be R naught equals to A over 2. That's the first thing. Okay, so what happens in the second place is that this is the angle of deviation at all time. Now, but at minimum deviation, that is going to change. The our I here is not going to be I naught. Our E also is going to be I naught since I is equals to E. And then from there we can deduce that. So from there we can deduce that I naught is going to be equals to minimum deviation plus A over 2. If you make I naught the sort of formula of this simple equation here, this is what you are going to get. And then we now move on. So we can remember that from Snell's law, we have that the refractive index equals to the sine of the angle of the incident ray to the sine of the angle of the refracted ray, and then sine of the angle of the incident ray. Now, our incident ray that we are going to use here is not going to be our I naught, and our refracted ray that we're going to use now is going to be this R naught, and then that is it. Then we have D plus A over 2 divided by sine of the refracted ray. So this, what we have here is this, and what we have here is this straight and direct.